Welcome back to 15th Street Automotive. Today we're working on a 2020 GMC Canyon 3.6 liter engine, four-wheel drive. Customer's concern is it's got a ABS light and traction control light on in the dash. They didn't notice any problem with the function of the vehicle, but lights on in the dash, and they want it diagnosed and taken care of. So we're going to diagnose it and let her know what's wrong with it. Alright, as you can see, the ABS light is on and the traction control light is on. So we're going to check our scan data and see what we see. Alright, there's codes in just about everything. ECM says there's no response. That's not good. Check codes. Oh, great. Lost communication with the electronic brake control module. Wow, it's the same code in all of them. Lost communication, invalid data. I'm suspecting we may have a problem with the electronic brake control module. So yeah, down here, ECM, no response. So I guess the best thing to do is we're going to have to check powers and grounds on that module. Before we do that, let's make sure our bus is working, and we got both of our terminating resistors in there. Once we do that, we'll figure out where the ECM is on this thing. I think it's on the frame rail. We'll check powers and grounds, communication circuits, and go from there. Alright, so we're going to use my breakout box here. We're going to go 6 and 14, and we're going to check resistance on that. See if so what we're looking for is if the two terminating resistors in the CAN network, the electronic brake control module, are both present, then we know that structurally the CAN network is still in one piece. Not to say that we don't have a module down or something like that, but at least like we don't have a broken wire or something in between the ALDL here and the ECM. So what we do is we'll stick our multimeter in across the CAN network, which is pins 6 and 14, and as you can see there, we've got 61 ohms. So the terminating resistors, there's 220 resistors, one on either end of the network. Two resistors wired in series, or wired in parallel, sorry. You divide by the number of resistors, and at two 120s divided by 2 is 60. So that tells us that the network physically is intact. We don't have a broken wire, but we may have a failed electronic brake control module. So the next thing to do is we'll go down, find the ECM, pull the connector, and then start checking power ground and making sure that there is a communication signal at that connector. So before we go hunting for the electronic brake control module, I think we're gonna. I hooked up the Pico. I want to look at the CAN waveform just to see that maybe that might give us some insight as to what we're looking for. So I'm gonna get this all hooked up, and then we will. I'll show you what I got, what I find in. Okay, so this is my setup. I got the blue channel in the high can and the red channel in the low can. Those are my grounds, just going to the chassis ground. I got my Pico leads here. Key is on, so the network is active, and you can see 6 and 14 are flashing there. When I was doing my resistance check, you want the network asleep, so those lights were out, if you remember. Anyway, I got to show you this humble brag I got. So all of my boom pieces I got from Jarhead Diagnostics in North Carolina. Brandon Dill. Awesome stuff. Been using it. It's been great. The case for my Autel VCI, the boom pieces here. All these light blue pieces are all from Brandon. But being a inventive guy like I am, I decided I wanted to get a 3D printer and try this stuff myself. So I bought a 3D printer and built this little cup, the boom cup, so I can put stuff in here. There's a hook, but there's normally contacts in here and clamps and pins and everything else. But my latest creation, and I'm very proud of, is this Pico box here. I made it with purple because that's what I had in my printer, so it's purple, but it's kind of cool. But I took all the dimensions for the back of the Pico and the tab that they used to hang from, and made the openings for all the connectors. And then in the front here is it's just open. It just kind of slides in there. What holds it in there is on the back of that Pico there was a bolt, I believe it's for a ground strap, but it's a little 4mm bolt that I just made a hole, printed the hole into the back of it, right where that threaded part was, and so it bolts in. So it's steady in there. It's not going anywhere. But then I made the boom opening there with a clamp. What do they call that? Clamshell. So I can hold it in there. I even made a plug for the end of it, end of the pipe opening. So there's my humble brag for the day. Pretty proud of that sucker. Works awesome. I think it looks cool hanging on the end of the boom too, kind of like a cobra head. But anyway, we're not here to look at my shit. We're here to look at Pico. So what I've got here is, it's not a bad looking waveform. Let me stop this thing, and we'll go in and open something up here. Let me get a smaller one so it doesn't take up so much space. Let's see here. Okay, so you see how these things mirror each other. If we pull this one up, you can see how as this goes up, the red and the low goes down. It mirrors them. So if we get a high pattern, we got to have a low pattern that mirrors it. So it's got to be like that. But if you'll notice, when the modules are talking, so this is one of the modules online. It is at 2.5 volts. The base is. So the low goes down and the high goes up from that 2.5 base. But if you'll notice, as soon as that thing stops talking, that bias voltage, that base voltage rises to like 2.8 here. Actually, it's over here at, what is that, like 2.9 volts. So that tells me that when that module, when the modules that are functioning are no longer talking, something is bumping that base voltage up. That points towards a ground problem. It almost has to be a ground on the EBCM because that's the only module that's not communicating, and everybody's pointing at the EBCM as the non-talker. So that's a real good indication as to where we need to direct our time in diagnosing. So if we move this along, let's see what happens as we go. See, that goes all the way up to 2.9 volts, and it's both of them. You can see if there, you get real close, you can see that it's red and blue in there. So let's pull this over. It's moving up and down because I'm panning, and I'm not panning evenly across. Here, let me go out a little bit here. Okay, here's another one. Yeah, see, as soon as another module talks, it pulls that down because that module's ground's okay. So when that's talking, the 2.5 is fine. As soon as it's done talking, so right here is where the EBCM is supposed to be. I would assume. You know, here's a couple more modules talking, and this one's saying, "Hey EBCM, where are you?" And there's nothing. "Hey EBCM, where are you?" And then another module goes, "Hey EBCM, where are you?" And nothing. So our problem. Yeah, look at all these modules are talking, and they're saying different things because there's different pulses in there, but they're all talking at that 2.5 volt baseline. And as soon as they're looking for somebody else to talk, it goes up to 2.9. So our problem is a ground. I would bet on it. Let's go underneath the car, find the EBCM, check our powers and grounds. Not going to be a communication problem. Well, it is a communication problem, but I don't think it's not a network problem. It's going to be a module problem, possibly a module or a ground to the module. But next step is putting this thing up and figuring out what the heck's going on. Alright, so this is our battery maintainer. I'm going to be doing some tests down there with I have to have the key on to check powers and grounds. So I always like to use a battery maintainer so that if our battery's marginal, we don't lose our voltage that we're supposed to have, that we're expecting to see, and then we get erroneous tests and we're chasing the wrong thing. So it takes 2 minutes to hook up a battery maintainer, and then you got what you need. We use a Top-Don 120 ampere. I really like it. It's kind of big, but it sure works nice. It's got a nice display. You can count on it. It gives steady voltage, so I think it works good. All right, I had to close the door back there. It was blowing the screen out. So now that we can see what we're doing. So this is our EBCM. Not bad to get to. Some are easier, some are a hell of a lot worse. So I'll take it. It's not bad. So I'm going to disconnect this thing. Now this thing's kind of covered in mud and dirt, and these connectors get packed with mud, and you can break these releases. If you watch any of my videos, you've seen where techs have He-manned these connectors on these things and they break. The locks break, and you're stuck with either this one's already been opened because the zip tie is broken on it. But you're stuck with either replacing this connector and repinning it, which is a pain in the ass, or I did a Denali here not too long ago. I had to zip tie it because it was going back to the other shop to do the repairs. I doubt they replaced the connector. I'm sure they they left my zip ties in there to hold it on. But anyway, we're gonna get this off. I'm gonna blow it out, spray it out. WD-40 or PB blaster on this thing, and then an air gun will get a lot of that crap out of there, so you can actually get in there and get it released. But we'll do that. I'm gonna pull up a wiring schematic so we know what pins we're looking for. We're gonna check the grounds on this thing and the powers, and make sure communication's getting to it. Although I'm sure it is, because we've got a good pattern, a good CAN pattern. We just don't have communication with it. So could be a bad module, But let me get this cleaned out. I'll get the schematic and then we'll continue on. Oh, boy, that baby didn't want to come out of there. Okay. Yeah, you got to be careful with these things. You break them. That one's flowing nice now. So what happens is you got this arm that you slide back and forth, and when you open it all the way up, it's got the openings that take these tabs right here, these little nubs, and as you rotate this around, it cams inside there and pulls the whole thing in. As you cam it down, it pulls it in. What happens is you get dirt in there, and this is just cheap plastic. You get dirt in there, it doesn't want to move, so you force it, and then these things break, and then there's nothing to hold it in. You can still, if you broke this thing completely out of there, you can still push it in, but there's nothing holding it, clamping it in. And then the weather packing interior seals in there, they don't seal because they're not held tight. It's a pain in the ass. So, worst case scenario, and I am not for this, but I've had to fix them like this before, is if these are broken and you can't get a connector, put it on there as tight as you can, and then get a large, not a normal standard zip tie, but get one of the big thick ones, wrap it around there, lock it down, and it'll hold it, and if you get it tight enough, it'll hold it, hold that weather packing seal tight. It'll work, but it's not good. So clean them off before you start pulling them out, and like I said, a little PB Blaster WD-40 in there makes that thing slide a lot easier. I didn't have to do that, but I was getting ready to. So anyway, there's our ECM right here. Here's our connector. I gotta get the pin out to figure out what the powers and grounds situation are on here, and then we'll do some tests. Alright, so I printed out the schematic. It's pretty simple. What we're looking for here, these are all the communication lines, but we're not probably going to need to go there. I think our problem is here. We got two powers coming in here off of fuses from the underhood fuse block. I already got it up in the air, so I'm not even going to put it down. I can check it right here at the connector. And then one ground, but see, it's going to be a big ground because normally, a lot of the times, this is the motor, this is that pressure modulator motor. Usually it's grounded, it has its own ground, but this one here, if you look here, it grounds through the ECM. So this is going to be a heavy duty ground. This isn't going to be like a 16 gauge ground. That's going to be much bigger than that. Those motors take like number 6 or number 8 wires to ground, so this is going to be a big fat ground. But let's check our powers. We're going to load test them, obviously. Always want to load test. We're going to load test our two powers. They are on pin 1 and pin 25, and then we're going to load test our ground, and that's pin, looks like 13. See what we got there and go from there. Alright, so I got my test light. That's a big old fat H13 headlight in there. This is, so I believe it is either 4 or 5 amps, which would be plenty. to test the circuit. But I'm going to put one in the ground and one in the power, and that's going to tell us if we have power and ground. So that'll test the ground circuit and both the powers. So that's pin 1. You can see that it's stamped on here. It's hard to see, but that's pin 1, and then it's 2 to 12, and then 13, and then another row, and then this is 25 right here. So 1 and 25 are our powers, 13 is our ground. So if we stick this in there, we stick this in here, we should have power. We don't have power at either of them. We need to check our fuses possibly. Let's see here. Let me go to a different ground. Oh, there's our power. So if I scratch this, that tells us something right there. So if I scratch this lead on the bolt here that holds the ECM on, I get my power on there. You see that? But if I plug it into the ground, that is our ground, we get nothing. Let's check 25, that's our other fuse. And we know we don't have a ground, so we're not gonna get it. Let's check our scratch ground here. Oh, there we go. That's that explains a lot. So we have powers, we don't have ground. And you know what? That explains that can signal that we had, to where it rose up to 2.9 volts, where it's supposed to be stuck at 2.5. A bad ground here would explain that, because every time this module is supposed to talk, there's no ground there, so it raises the overall voltage up on that line. So we need to go after where this ground is, and it's a burly connector in there. I mean, it's the biggest one in the whole connector is that ground. So it's going to be a larger wire. Here's a couple big chunky wires here. Here's a black that's probably what, an 8 gauge maybe. Big old chunky wire, and there's the power that goes to 13. So those are big wires because of that pump. That pump takes a lot of juice to run. This pump right here. We need to figure out where that ground is, and we'll do a voltage drop on that ground and see what we got going. But that explains our no-com. It explains our funky pattern on the Pico for our can signal. I'm gonna go ahead and close this up so I don't forget. I'm gonna spray some lube in this thing so it goes a little smoother. So we use a PB Blaster here. I like it. It seems to work a little better than WD-40. It's expensive, but it works good. Yeah, that smooths it up a lot. Oh yeah, look at that. Nice and smooth. Put our lockdown in there. Okay, so let's figure out where the where the ground is. It's I think it's said G400 on the schematic, but I have no idea where it is. So that's what we have all data for. We'll figure it out. So if I type in G400 here, it gives me, I go to this ground distribution schematics, and I should be able to find where G400. So if I looked here, I'd looked at this schematic, and it tells you where the ground is. This G400 is right there. So the G401 is for an LWN vehicle, which I think means crew cab. This isn't a LWN. It wasn't in the RPO code, so but I think not LWN is the extra cab, which is what this thing is. This is, I believe, is crew cab. So we're looking for G400, and if you go up in here to the figure 13, it shows you where G400 is. Look on that. I'll blow this thing up. So G400 is right here. It goes through a junction, J404. Not sure where that is. But you can see here EBCM, brake fluid level switch, and a trailer connector. This is not a Z, it says with Z82 or no Z82, and this doesn't have Z82, so or it does have Z82. So this that's basically a trailer package. So G400 is right there, and it has the EBCM on it. So we already knew that, but it has a junction 404 on there. So let's figure out where that is on the vehicle. Ground views right here. Ground views 400. 400 extended cab, which is what we have. All right, so let's see here. This thing is there's a leaf spring. There's the axle, body mount. So it looks like it's attached to the frame at the body mount right behind the cab. Oh, that should be easy to get to too. So let's figure out what the heck. Let's if we voltage drop, let's see if we can find this thing, and we can voltage drop from here. We'll just voltage drop from here first, and we'll use my headlight as a load test, and then we'll pull that connector back out and see if we get anything there with a load test. Well, we already did that, so we didn't get anything. So let's go see if anything obvious on this, and then we'll go from there. All right, so I found our problem. This is G400 right here. That's our ground, and that's where it's supposed to be. And the bolt is broke off on there. If you look back here, the stud for it's still there, but the head of it's broke off. And if you look inside there, I don't know if you can see that, but it's all rusty. There is like a little pinpoint of actual steel showing through. The rest of it's all just rust. So at some point this thing gave up the ghost and became disconnected. I mean, it's pretty crusty in there too. So this thing's, what we're gonna do, I'm sure this is all their problem, but what we'll do is we'll I'm not going to worry about cut or drilling and tapping that. I'm just going to clean this up real good right here, and I'm going to clean all this up real good. I'm just going to stick a bolt with a lock washer and a nut on there to lock that in and give it a good ground, and then that will give us that'll give us what we need to get a good ground on that. So let me clean that up. I'll bring it back when I'm all done and show you my work. And then we'll check our scan readings and see if we don't get communication back. All right, so I got it fixed. I've got it just in that extra, that whole upper hole that used to hold that little tab there. I just ground off all the paint and mud and the dirt and rust and everything off of there with my grinder. surfacing wheel. And then I got a nut washer, split lock washer, and a nut on the back. And that will, and it tightens it, holds it tight. And I sprayed the whole thing with battery protector to keep it from corroding and rusting. We don't have a problem with rust up here, so it won't. It's not like Ohio where you gotta, you know, paint the thing with 3 different coats of paint. But battery protector should work really well. It'll keep the corrosion down. It's better than it was from the factory. They don't have any kind of sealant on it except for undercoating. But let's, with that thing fixed, let's check our scan data to see if we get any communication back. And then I kind of want to see the Pico again to see if it is showing a better signal. See if that 2.9 baseline goes away. So let's take a look at the scan data.
Connected by OnStar's high-speed 4G connection. Press the blue OnStar button to learn more.
Okay, we still got all the oh, EBCM's got communication now though. So let's do a quick erase. We didn't have EBCM communication before. Some of those codes are going away. What do we got in there? So a couple of them are still saying there's no communication. Okay, that says, so our EBCM's back online here. That's good. Let's do another fault scan. Okay, no codes. That's good. So topology, all of them are green. That's good. Let's start this thing up. And our ABS light is out. Awesome. Okay, no codes. No ABS light, no traction control light. Here, with it running, let's do another fault scan. BCM has some codes. What is that? But ECM, all the communication codes looks like they're gone. List. Oh, tire pressure monitors. I'm not worried about those right now. I think this thing's got aftermarket wheels on it. They probably didn't even put sensors in. Cool. Hey, let's look at the Pico waveform. I want to see if that's different now. Okay, so I got the Pico hooked up back up to the breakout box. Let's start another capture here. Let's see here. Move these up. Remember, you gotta have the key on to get network awake. Let me pull this thing down. Let me get rid of my zoom here a second. Okay, so I don't know if you can pick this up, but this line here, the base voltage line, where the high goes up and the low goes down, it's rock steady at 2.5. So if I bring my cursor down here and measure that center line there, 2.475. We're back to normal. There's no 2.9 left. So if I freeze this, let me freeze this thing here. And let me pull it up a packet. Let me pan over a little bit so I can get it here. So now if you look here, let me pull you in a little closer. If you look here, our blue and our red line are on that same line. I've got them here. If I move this up, you can see that I've just got them stacked on each other just to show how, just to put them together so I can look at the mirroring. But so that's right at 2.5 volts. 2.5, the high side goes up to 3.5, the low side goes down to 1.5. That's textbook. That's a textbook CAN signal. Before, when these things weren't talking, it would rise up to 2.9. It would rise up to about this level right here. And in between each one of these little packets here, let me zoom in on one of these single packets here. So every time this thing would talk, and it'd be talking at 2.5. As soon as it stopped talking, this would rise up to 2.9. And then the next one would talk, and it would pull it back down to 2.9 or 2.5. But now that whole thing, let me go out a little bit. That whole thing is rock steady at 2.5. Our problem was the ground the whole time. Everything was caused by that ground. And obviously that's a big ground, so it's going to cause a lot of problems. So when you're talking about a ground that size, that's completely disconnected and hanging in the air, you're going to have some things not working. That ground was the size it was because it also grounds the motor, which takes obviously a lot of voltage. But that's what goes to show what that ground can do to a communication. It allowed that base voltage to rise up. That was a good diagnostic indicator of what was happening there. So it was a good find. It was a good fix. Didn't take long. This one is this one's a fix. Customer's going to get the car back without any major needed repairs. So it's a good day. Thanks for watching.